Bismillahirrahmanirrahim. Welcome to the new topic, which is the interaction of ionizing radiation with matter and its loss of energy. So first look at this image and just for a while stop the video and just concentrate on this image, what information you are getting after looking at this image. And these are the different particles or the radiation, alpha, beta, and gamma. And this is the mass. And if you have concentrated over here, and then you will find the actually the objectives of our this lecture or the coming lecture. So what are the properties of radiations? And because there is, you may say there is a different penetration over there in the mass or in the human body. So what would be the interaction of these radiation and loss of energy? And the third objective would be the measurement of these radiations. So these are our objectives for the coming lectures. So in the first video in this lecture, I'm going to explain the properties of different radiations, and then you will better understand what would be the interaction of these radiation with the matter and its loss of energy. And then we will move to the measurement of these radiations, because this is important to understand the first two objectives, and then we will see what would be the way to measure all these type of the different radiations. So the first property is the penetration power. So penetration power, again here, if you have a look at this image, so there are the three radiation: basic radiation, alpha, beta, and the gamma radiation. So it is actually, and some of the words are given over here, and these are some of the blanks over here, and you have to fill all these blanks with the appropriate terms, and then we will decide what will be the penetration properties of these radiation. So let us start. Actually, these are the different way uh, in which the radiation is going to pass. And this is the first, it is a sheet of paper, and here it is a few millimeter of the aluminum and a few centimeter of the lead. So you just concentrate over here. So alpha is going to be stopped by the sheet of paper, but it is going to allow to pass the beta and the gamma radiation. And again, if it is the aluminum sheet, it is going to stop the beta, but it is going to allow the gamma radiation. And of course, the lead is also allowing the gamma radiation to pass through it, and you need some other material which is going to stop these radiations. So it is, if a substance is capable of always emitting the radiation under any condition, and we say it is the, what is the radioactive. So these are the, sorry, there are the three types of the radiation: alpha, beta, and the gamma radiations. And these types of radiation are always given off by rocks and by food, building materials, air, and cosmic rays around us. And this is called the background radiation. So you are actually in a, so you are surrounded by the different type of the radiation which are around us, and these are called the background radiation. Some are dangerous and some are not dangerous to us. So it depends on their penetration power. This is the one of the properties over here, and each type is capable of penetrating the different materials. So I, as always, as I have already explained over here. So penetration power over here, if you have concentrated on this image, and you have concluded that the penetration power of the gamma is more as compared to the beta, and beta is more as compared to the alpha. because you can stop the alpha radiation with the paper, but you need another strong material to stop the beta, and further a strong material to stop the gamma radiation. So gamma radiation is going to pass through the different materials having more penetration power as compared to the beta, and beta is more as compared to the alpha radiation. So you may also say that why the gamma radiation is having more penetration power, because it is only the energy, not having the the charge over here and the mass. But here this is beta is the mass or the electron, and having the charge -1 or the +1, it depends on the electron or the positron. And alpha is also is having a mass but having the +2 charge over there because it is the alpha nucleus. So that's why it also depends on the mass and the charge. Second property, which is more important, is the ionization power of these radiation. So it is also that means the dangers of the ionizing radiation. And ionizing radiations are the alpha, beta, and the gamma radiation. We also call them the ionizing radiations because they have the ability to ionize the material or the matter. So radiation will ionize atoms in living cells, and this can damage them and cause the cancer as well. So this is very, very important topic to understand the ionization power of the different radiations, because these are going to cause the cancer. So again, concentrate on this image and uh, the type of the different radiations, alpha, beta, and the gamma radiations. And you have already learned this is almost we have done in the previous slide. This is the penetration power of gamma, beta, and the alpha, which is more, less, and further less. So actually, there are the you can conclude this topic with the two important conclusions, and one is the what is the outside the body and the inside the body. Outside the body is the alpha or little bit the beta, and inside the body you can also say beta or the gamma radiation. So outside the body, that is the beta and the gamma. So this is the beta and the gamma are more dangerous as alpha radiation is blocked by the skin. So if it is the outside the body, because alpha radiation is blocked by the skin and even it is stopped by the paper. So outside the body, beta and the gamma radiation are uh, very dangerous because they are going to penetrate into the body. But this is another important conclusion over here. But when it is penetrated, let's suppose alpha is penetrated, it depends on the how much is the type of the material and or the energy or the energy of the alpha particles. So if it is penetrated into the body, and if let's see if these three radiation are inside the body, so inside the body and alpha cause the most damage because it is the most ionizing radiation. And this is because when it is penetrated, let's say all three radiations are penetrated into the body, then alpha radiation is more dangerous because this is more ionizing radiation because of having a mass, and it's having a +2 charge because this is the helium nucleus, and helium nucleus is having the +2 charge over here. And when it is penetrated into the body, then it is going to cause more ionization uh, into the material. That's why alpha is more dangerous as compared to the beta and the gamma radiation. So it depends outside the and inside the radiation. So this is the little bit comparison of the radiations as I have explained before. So alpha radiation is having more ionization power as compared to the beta, and beta is more as compared to the gamma. And some of the examples are given over here. Let's suppose the alpha radiation or the alpha particles is having the ionization power. We call it the specific ionization, which is the 5 to 10 exponent 4 ions per centimeter, and the beta is 5 to 10 exponent 2 ion pairs per centimeter, and gamma or the X-rays are having less than 10 ions per centimeter. So actually the number of ions produced per unit of the path by the incident radiation is called the specific ionization. Because when you compare the ionization of one particle or the one radiation with the other radiation, you have to keep in mind to take the constant amount of the material or the length of the material. So this is per centimeter. So if you take 1 centimeter of the same material, so in 1 centimeter ionization power of the alpha is more as compared to the beta, and beta is more as compared to the gamma radiation, and this is called the specific ionization. So ionization is the just the production of the ion pairs, that means positive and the negative ions, and the specific ionization is ion pairs per centimeter. You have actually to take the constant amount or the length of the material to compare the number of ion pairs produced. So it is expressed in IP, ion pairs per centimeter. So these are the two factors actually in which this is going to depend. One is the ionization, the specific ionization. This is going to increase with the electrical charge of the particle, as I have explained, because alpha is having more charge, that's why it is having the more specific ionization. Second, it decreases with the increased incident particle velocity. Actually, and here it is the particle velocity of the gamma radiation is more, and that's why it is having the less specific ionization, because it is having the more velocity, so it is immediately going to pass through the material having less ionization per centimeter of the material. So these are the two factors in which radiation is going to depend, and this is the overall view. The third property is the shielding of for the radiation. And first is how can you reduce the radiation exposure. This is the one natural thing is the you can limit the time. That means if you limit the time, you have the less time spent near the source, and there is the less radiation received. And other one is the you can increase the distance from the radiation. So greater the distance from the radiation will be there will be less radiation received. And this is the third option. That means you have to use the shielding, and you that means you have to take some material to stop all these radiation, and this is called the shielding. So behind the shielding from the source, less radiation received, and this is uh, uh, the effect of the shielding of the radiations. So again, this is the comparison of the different radiations, alpha, beta, and gamma. And again, alpha is the helium nucleus. It is a bulky material, two protons, two neutrons, having more mass. So it can be stopped by a paper or the skin. But this paper or the skin is going to allow the beta or the gamma radiation or even the neutron, and you may have the aluminum foil, which is going to stop the beta, but it's going to allow the gamma radiation. And then you have the lead, it is going to stop the gamma radiation, but it may allow the neutrons because these are the fast energy neutron as compared to the gamma radiations, and they can be stopped by the heavy wall of the concrete. So if you compare the the shielding required, that means how can you protect yourself from all this radiation, then in case of the alpha, you need a more strong shielding as compared to the beta, and beta as compared to the alpha. So that means shielding in case of the alpha is required more, and then beta, and then for the alpha. So these are the three basic properties of the ionization or ionizing radiations, and this we will apply this knowledge to further understand the concept. So see you in the next video.